Fourier series session 3, Euler's formulae and particular cases. Let us start with this topic today. So to start with the Euler's formula, first of all we are following the single valued functions f of x. We are considering that and trying to find the answers. So the single valued functions f of x. Now the interval that we are going to consider is either in L form or in the pi form. We are going to consider in two cases, L and pi. If we consider in L case, the indefinite functional Euler's formula can be written as, in the case of L, is f of x is a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L. Now in this, either we can take summation, the whole bracket, or for each of the terms we can take the summation terms. Now here we need to find a0, an and bn. So let's first write down what is a0. a0 is what? 1 by L. So we are considering L. So 1 by L. Integration from fx dx. And an is again 1 by L integration fx cos n pi x by L into dx, and bn is 1 by L integration of fx into sin n pi x by L into dx, if you are considering in the interval L. Similarly, if I consider the interval pi, I am going to get the Euler's formula as for the indefinite integral value without the limits. We are doing this. So f of x will be what? Again a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by, in place of L we need to substitute what? Here pi, plus bn sin n pi x by pi. Here pi gets cancelled, so I am remaining with a0 by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. See, this is my f of x in the interval pi. This should be the whole brackets because the summation is for both the terms. Now here also we need to find a0, an, bn. So what is a0 here? 1 by pi. In place of L, it is pi. Integration fx dx, and an is 1 by pi integration of fx. When we substitute pi gets cancelled, so it is cos nx dx, and bn is 1 by pi integration of fx sin nx dx. So this is the formula that we are going to use for the Euler's formula, single valued function in the interval L pi. These are the formula for L, and this is the formula for pi. That is, we are going to use. Now, if at all we consider the cases when we are considering within the interval, definite integrals. When we consider the definite integrals, how does it look? So the single valued functions, f of x, when we consider in the limits a comma a plus 2l, if we consider like this with period 2l, the period is 2l here. So if I consider, what do I get? Fx is again a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L. This, the formula doesn't change, it is as it is. But when we are finding a0, an, bn, here we are writing a0 is what? 1 by L integration from, we know the interval, it is from a to a plus 2l fx dx. Similarly, an will be what? 1 by L integration from a to a plus 2l fx cos n pi x by L into dx. Similarly, bn will be 1 by L integration from a to a plus 2l sine n pi x by L into dx. So this is the formula when the given intervals, when we consider the interval, it is between a to a plus 2l. So if we are able to write this and find out the coefficient a0, an and bn formulae is called as Euler's formulae and also known as Fourier coefficient. It is also known as Fourier coefficient. Now let us consider the particular cases. If we consider the particular cases in this, case 1, where a is minus pi and L is pi. If I consider a as minus pi, then the f of x, single valued function f of x, is defined in which interval? From minus pi to pi with period 2 pi. Sorry, with period pi. Now let us write the formula. For fx is a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by pi. Pi gets cancelled. So it is just cos nx plus bn sin nx. And the Euler's formulae are a0 is 1 by pi integration from minus pi to pi fx dx. And an is 1 by pi integration from minus pi to pi fx cos nx dx, and bn is 1 by pi integration from minus pi to pi fx into sin nx dx. So case 1 we studied when minus pi to pi, a is minus pi and L is pi, then how the interval changes, and we have found out this Euler's formula for the case 1. Similarly, let us find out for case 2. When a is 0 and L is equal to pi. So f of x is defined in the interval, then we know it is a comma a plus 2l. So what does it change? A is 0, so it becomes 0. 0 comma 2 into pi, so it becomes 0 comma 2 pi. With the period, what period we have? With period pi. L is my period, so with period pi. So the formula again, it will be what? F of x is a0 by 2 plus summation n is equal to 1 to infinity a, and since it is with period pi, it will be cos nx plus bn sin nx. Now the Euler's formula, we need to find out a0. a0 will be, period is pi, so in place of L it will be pi. Integration from the intervals is 0 to 2 pi fx dx. Bn is 1 by pi, integration same limits, intervals 0 to 2 pi fx sin nx dx, and an is 1 by pi, integration 0 to 2 pi fx cos nx dx. This is the case 2. Now let's consider the case 3, that is if I consider the function fx in the interval minus L comma L with period what? With period L. So what happens? You know the interval actually runs from a to a plus 2L. Now in place of a, it is minus L, and here it is in place of a, it is minus L, and you are going to write a is minus L comma minus L plus 2L. So it will be what? Minus L comma plus L. So it is running between minus L to plus L. Now let us write down the Fourier formula. Fx is a0 by 2 plus summation n is equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L. This whole bracket. Now what is a0? a0 is again 1 by L, because that is the interval, and it is running between minus L to L interval fx dx, and an is 1 by L integration from minus L to L fx cos n pi x by